Welcome back. We are in the Math Models packet, problem 1.3. It looks like this, and you need this little piece of data so that you can fill the table out. So, a company called Custom Steel Products, CPS, provides material to make beams and staircase frames. So they're putting these 1-foot long steel rods in this pattern. So we're going to write down how many beams are needed right here for the different lengths, how many rods are needed for each of the different beam lengths. So for 1 through 8. So let's go ahead and look and see what this will be. So a beam of 1 foot would have 3 rods. So this 1-foot beam right here has 3 rods. Then a 2-foot beam is going to have 7 rods. 1, 2, 3, 4, 5, 6, 7. So a 3-foot beam, you would start with the 2-foot, and then you would add the same exact thing, a triangle each direction. So that would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 rods. So let's go ahead and add that. And then a 4-foot beam, you would just do the exact same thing, but you would add 2 more triangles. So each time I've added this and this. So every time you're adding 4 beams. So the 3-foot beam would be 11. The 4-foot beam would be 11 plus these 4, which is 15. So the 5-foot beam, you could keep drawing them, or we'll keep our pattern going and see if this is what we get. So remember, we have decided that we will add 4 every time because that's the pattern. So this would be 19. That would be 23. We do land right smack dab on 27, so this is good. Whoops. And then 31. So we're going to make a graph of this table. So the bottom here is the beam length. And the side is the number of rods. And that whole story was CPS Beam Company. So you always want labels and titles. So in our table up here, our x value went up to 8 and our y value went up to 31. The y is already numbered for us. The x's, it appears that we're just going to count by ones. Okay, so 1 gives 3, and this, hold on a second here. Here we go. We do have numbers. It's just me that has perfect. Okay, so 1 gives 3, 2 gave 7, 3 gave 11, 4 gave 15, 5 gives 19, 6 gave 23, 7 gave 27, and 8 gave 31. So describe the pattern of change as the length goes up by 1, the number of rods increases by 4. Put adding 4. That's important because it could be multiplying by 4, subtracting 4. How is the pattern in the table described and how is it shown in the graph? So in the table, in the y, you just add 4 each time. And in the graph, every time you go over 1 in the x, you go up 4 in the y. Over 1 space, up 4. Over 1, up 4. It would not make sense to connect these dots on our graph because you wouldn't be able to have a beam length of 1.5 because you wouldn't be able to have that full triangle. So these dots are just separate dots with no line connected. And then it says how many are in a beam of length 50 feet. So you can either write an equation. You can figure out how many more times to get 50, so how many 4s you add. You could somehow extend the table or the graph, but that seems quite a bit of work. Okay, so if we're going to go to 9, you'd get 35. And if you go to 10, you get 39. So how many more spaces do you go to get to 50? Because every 1 space you add 4. So you would go 40 more spaces. So 40 more 4s being added is 40 times 4, which is 160. So that's one method. The other method is to go back and find your 0 and to write an equation. Now, you did this last year, if you remember. So to go back and get your 0, you would have to subtract 4, because from here to here, you add 4. So 3 minus 4 is negative 1. Now, if you remember, y equals mx plus b. M is the slope, and b is the y-intercept. So when x equals 0, what does y equal? So we just figured that out. When x equals 0, y equals negative 1. So negative 1 is your b, and your slope is 4 because you're adding 4 every time. Now, 50 feet is the beam length, so that's y. In fact, instead of writing x and y, you can write this in words. Beam length is x, number of rods is y. Did I just say beam length was y? Beam length is x, number of rods is y. So I'm going to write this equation as number of rods equals 4 times beam length minus 1. So the beam length is 50, so that's 4 times 50 minus 1. So 4 times 50 is 200, and 200 minus 1 is 199. So 40 times 4 is 160, and you have to add that to the 39 to get 199. So the answers match up. Okay, for the next question, we're going to do this lovely diagram, which is a staircase. So 1 step, you need 4 rods. 2 steps, you need 10 rods. 3 steps, you need 18 rods. So 4 steps, you would add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you would add 10 more rods. So that'd be 4 would give you 28 rods. If you had a 5th step, you'd add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 28 plus 12 is 40. So let's go to that table. So 28, 40. So every time you have another step, you have to add in another chunk. So this time we added 10. This was plus 10. This time we added 12. If you look at the time before, 10 plus 8. Hold on. This is a plus 8. 10 plus 8 is 18. So plus 8, plus 10, plus 12. So every time you are adding 2 more. So this is plus 6, plus 8, plus 10, plus 12. So the next one you would add 14. Then you would add 16. Then you would add 18. So we're now going to plot this. Here, remember this. So we have 4, 10, 18, 28, 40. So 1 gives 4, 2 gives 10, 3 gives 18, 4 gives 28, 5 gives 40. We're going to have to put the labels on in just a minute. And then 6 is 54, 70, 88. So 6 is 54, 7 is 70, 8 is 88. And remember, our x value here, is number of steps, and our y is number of rods. And your title could be CPS Stairs, or whatever you want. Okay. This is not linear because the pattern is as x increases by 1, y increases by 2 more each time. And then it says, how is the pattern described? Shown in the table. Well, if you take the numbers, this is kind of a cool thing to talk about here. We have the first difference. If you find 18 minus 16 is 2, 16 minus 14 is 2, 14 minus 16 is 2, this is called the second difference. So this is the first difference. And this is actually called the second difference. So for the pattern, let's write that the second difference is constant. And in the graph, this distance is a little more and a little more and a little more and a little more. So the graph, it's showing a curve up. Getting steeper and steeper. So then it says how many steel rods are in a staircase frame with 12 steps. Now, this curve is called a parabola. And one of the last units we do this year, you will write equations for this. So this first section is just sort of introducing you to all these different types of patterns. So probably for 12, it's going to be easiest if we just extend our table, since we don't really have an equation to go by. So you would add 20, and then you would add 22, and then you would add 24, and then you would add 26. So 88 would be 108. 108 would be 130, because you just added 22. 130 plus 24 is 154, and 154 plus 26 would be 180. So 12 steps would be 180 rods. So how are these patterns similar? Well, they're both increasing. As x increases, y increases. So you might want to think of something different to write. How is it different? The stairs, what was that first one called? The beams, you're constantly adding 4, so it was a linear pattern. And the stairs, add 2 more each time. So it's a parabola, or it's a curve. Parabolas actually look like this. So we're looking at this part of the parabola, that curve part. We've kind of already explained how it is shown in the table and graph, so I'm going to cross that off. In letter D, this is talking about the bridge breaking that we did. So the first bridge break with the length, the first bridge was with thickness. So the first bridge break with thickness was linear, just like the beams. It was a best fit line. It wasn't a perfect line, but it was linear. And the second bridge with length was a curve. The curve was a hyperbola. It was going down like this. The bigger the length, the less pennies it was hold. And the curve of the stairs is that thing called a parabola, where it goes up. The more stairs needed, the more beams. So that would be one similarity slash difference. And I think that's all. So let me give you a problem to try quickly. And we're going to try the sheet that you have at home has numbers 3, 5, and 6 on it. So I'm going to kind of help you get those set up. So in number 3, you are using the exact same data as this. Where do we... Hold on. Did we not put that in a table? So in number 3, you're using the exact same data as we did for the very first problem. So the length is 1, 2, 3, 4, 5, 6, 7, 8. For the length of 1, you have that single triangle, which has 3 rods. And then every time we increased by 4. So 7, 11, 15, 19, 23, 27, 31. So the next part of this problem, number 3, is the cost of the beam. And it says that it's $2.25 for each rod plus $50 shipping and handling. So this is going to be $50 plus 3 times $2.25. You can figure that out and you can put the cost right in there. So the next one would be $50 because it's $50 shipping and handling times 7 times $2.25. So go ahead and finish filling out the table. And then you're going to make a graph of the beam length and the cost. So you're not going to worry about this middle part. So you're going to sketch a graph just on the side, just like a sketch with length on the bottom and cost on the side. So you're going to complete that right now, and you're going to bring that to class done tomorrow. The second part of number 3 is the same exact thing with the table of steps. And remember, we started at 4 pieces, then 10 pieces, we added 6, then 18 pieces, adding 8. Then if you add 10, you get 28. So you're just going to fill out this table exactly like we filled it out for the number of rods. And then you're going to fill in the cost. And it's the same thing. It's that $50 plus 4 for the first one times $2.25. And then you're going to graph steps with cost. So you're going to do that right now. And then you're going to move down to number 5 because there is no number 4. And number 5 is showing these same boxes where you stand on it, but this time instead of how many rods do you need, the question is how many boxes are there actually? So, the table that you're looking at, you're going to have to flip the page over now, is number of medalists and number of boxes. So one medalist has one box. Two medalists would be right here. Here's one person standing getting their medal. Here's the other person. So they have 3 boxes. 3 medalists have 6 boxes. So what do you think 4 medalists will have? You're going to add 4. So 10 boxes. And what do you think 5 medalists will have? You're going to add 5 boxes, which you're going to be off the page here. So that's 15. So you've added 2, then 3, then 4, then 5. You're going to take that all the way to 8. And then it's going to ask you for the length of carpet. So as you go up, it's 1, and as you go over, it's 2. So 1, 2, 1, 2. 1, 2, 1, 2, 1, 2. 1. Okay. So we have number of steps and carpet length. So for one step, you have 1 plus 2, which is 3 feet of carpet needed. For 2 steps, you have 1, 2, 3, 4, 5, 6 pieces of carpet needed. For 3 steps, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of carpet needed. So do you see the pattern going on here? Try to do the pattern and try to fill out the rest of that table. And then last but not least, number 6 says that this awesome company, CSP, also sells ladder bridges. So you're going to make a table and a graph showing the number of rods in a ladder bridge is related to the length. So basically you're looking at this bridge like this. It's on your paper. And this is like 1 foot. Each chunk is a foot. So if you had a 1 foot bridge, the rods you would need would be 1, 2, 3, 4. And then as you increase that to 2 feet, you would have to add 1, 2, 3 more rods. So 4 plus 3 is 7. And then if you increase that to 3 feet, you would have to add 1, 2, 3 more rods. So that'd be 10 because you're adding 3. So go ahead and fill that up to 6 and sketch a graph for this. So in your graph you need to have a title, and then your X value is length and your Y value is number of rods. Okay, so you should be able to complete numbers 3, 5, and 6, and that's due tomorrow when you walk in. Have a lovely evening.